Remember when a stomach ache meant the doctor might just say, well, let's open you up and take a look? Exploratory surgery, can you imagine? Thank goodness those days are long gone, and we have the amazing invention of the MRI to thank.
Yeah, it really is an incredible piece of technology, isn't it? Being able to see inside the body without any incisions.
No radiation either, unlike those old x-rays. But what I find even more fascinating is how it all came about, you know? The whole story behind the MRO.
Absolutely. It's a story with a lot more twists and turns than people might expect. A whole bunch of brilliant minds, chance discoveries, and even some pretty heated debates about who actually invented the darn thing.
Yeah, who really gets the credit right? It's a really interesting story that goes all the way back to the early 20th century, a time when physicists were just beginning to figure out the atom.
And the really interesting part is how a lot of this early research in physics ended up playing such a huge role in medicine.
Exactly. So to really dive deep into this, we need to start with a physicist named Isidore Isaac Rabi.
Right, Robbie. He was a real pioneer in atomic physics back in the 1930s. He came up with a way to study atomic nuclei using magnetic fields, which was like totally groundbreaking at the time.
And that work ended up winning him the Nobel Prize in Physics in 1944, right?
You got it. It was revolutionary research. I mean, he was actually able to detect and measure the rotations of atoms and molecules. Imagine that, a glimpse into the world of those tiny little particles.
It's amazing how far we've come in science. But how does Rabi's work actually connect to the development of the MRI?
Well, his research kind of opened the door for other physicists to really explore magnetic fields and how we can use them to study matter. And one of those physicists who got really inspired by Rabi was Felix Bloch. And he has a pretty amazing story himself.
Oh, yeah. What's so interesting about Bloch?
Well, for one, he had a really tough time early in his life, you know. He lost his sister when they were young, and then he struggled with depression during World War I.
Oh, wow.
Yeah, it was rough. But he found some peace in the world of math and physics, of all things.
It's funny how those things can provide comfort, isn't it? Turning to knowledge in difficult times.
It really is. But, you know, besides his personal struggles, Bloch did some seriously important research that had a huge impact on the world.
What kind of impact are we talking about?
Well, his work on metal conductivity was absolutely essential for developing a lot of technologies we just take for granted today.
Really? Like what?
Well, for example, he helped pave the way for switching from those big, clunky vacuum tubes to semiconductors, which led to tons of advancements in electronics.
Wow, I never realized how influential his work was. So how did he get involved in the MRI research specifically?
Well, he had an amazing career working alongside some of the biggest names in physics, like Werner Heisenberg and Enrico Fermi. But eventually, he ended up at Stanford University.
Okay.
And at Stanford, he became good friends with another famous physicist, Robert Oppenheimer.
Wait a minute, Oppenheimer. The father of the atomic bomb? Oppenheimer?
That's the one. And get this, they actually co-taught a seminar together, bouncing between Stanford and Berkeley for each lecture. Pretty cool, right?
It's mind-blowing that these two giants of physics were just casually teaching a seminar together. That's incredible. Okay, back to Bloch and his connection to MRI.
So in 1946, Bloch and his colleagues published a really important paper on something called nuclear magnetic resonance, or NMR for short. They described how the nuclei of atoms react when you put them in a magnetic field, and that discovery had huge implications for a whole bunch of fields, including medicine.
Okay, and that's where we get into parallel discovery, right? Because Bloch wasn't the only one to make this breakthrough.
Right. Around the same time, a physicist named Edward Purcell and his team over at Harvard published a paper on the exact same thing. And get this, they had no idea Bloch was working on it too.
What are the odds of that? It's like scientific synchronicity or something. But before we dive into Purcell's story, can you quickly explain why Bloch's paper was so groundbreaking? How does it lead us to the MRI?
Well, imagine being able to analyze how some material reacts to a really strong magnetic field and then use that information to figure out exactly what it's made of.
Okay, I'm listening.
That's essentially what NMR lets you do. It's like each type of matter has its own unique magnetic fingerprint.
I see. So you're saying that if different tissues in the body have different NMR signatures, you could theoretically use that to create images of those tissues.
Bingo, you got it. But here's the thing. Neither Bloch nor Purcell were thinking about medical applications at that point. They were all about the physics. They just wanted to understand how this stuff worked.
Gotcha. Okay, so let's shift gears and talk about Edward Purcell.
This guy sounds like a fascinating character. I hear he was super into his dad's electrical engineering work as a kid.
Oh yeah, Purcell was a curious kid. He loved digging into his dad's technical journals and just staring at all those diagrams and equations about electricity and math. It's kind of cute, actually. He even wrote about how much he loved nice diagrams.
That's adorable. Clearly a budding scientist in the making. He just loved to learn. He really did. And that passion took him to Purdue University, where he studied electrical engineering. But then he realized he was way more into physics, so he switched gears and eventually ended up at Harvard.
So he went from Purdue to Harvard. Not a bad trajectory. And wasn't he involved in the war effort, too?
You bet. During World War II, he worked on radar technology at the MIT Radiation Lab. A lot of physicists were doing that kind of stuff back then.
Right, it was a big push to develop new technologies.
Yeah.
So was it after the war that he and his team at Harvard made that big NMR breakthrough?
Exactly. In 1946, they published their big paper on resonance absorption by nuclear magnetic moments. It was basically the same finding as blotches. And you know what's really cool? Despite being rivals in this scientific race, Bloch and Purcell actually developed a pretty good friendship.
That's heartwarming. Shows the power of mutual respect, even in a competitive field.
It really does. And their friendship is reflected in the fact that they shared the Nobel Prize in 1952. Bloch even sent Purcell a telegram when he heard the news saying, "I think it is swell for Ed Purcell to share the shock with Felix Bloch."
I love that. It's so funny. Okay, so now we have these two brilliant minds laying the foundation for MRI with their independent discoveries of NMR. But here's what I don't get. Why was there such a long gap between their Nobel Prize in 1952 and the first actual MRI experiments in the 1970s? I mean, that's like 20 years.
It's a good question. It's a classic example of how sometimes in science, you need someone to connect the dots between theory and application. Like the potential of NMR for medical imaging was there all along, but it took someone with a different perspective, someone outside the world of physics, to see it.
And that someone was Eric Odeblad.
Yeah, Odeblad was a Swedish doctor. He was super inspired by Bloch's work, and he became convinced that NMR could be used to actually study human tissue. He even tried to get Bloch to let him use his NMR spectrometer, but Bloch wasn't having it.
Really? Why would he say no?
Well, at the time, Bloch just couldn't see past the physics applications of NMR. He just didn't think it would work in medicine.
But Odeblad wasn't giving up that easily, right?
Absolutely not. Odeblad was persistent. He went back to Sweden and managed to get his own NMR spectrometer. And in 1955, he published some groundbreaking research that showed the differences in proton signals from various types of human tissue.
So he was the one who took that first step towards applying NMR to the medical field.
He was a real pioneer in that sense. He really opened the door for the development of the MRI as we know it.
But the story doesn't end there, right? We're still a long way from analyzing tissue samples to actually scanning a whole human body.
You're telling me. And that's where the next chapter of the MRI saga comes in. It takes us to the 1960s and the work of an incredibly driven and ambitious scientist named Raymond Damadian. Now, Damadian, he's a really interesting character. He went through a lot. You know, he lost his grandmother to breast cancer when he was younger, and that experience, well, it really shaped him.
Yeah, I can only imagine. Losing someone you love to a terrible disease like that, it can really fuel a fire in you to make a difference.
It definitely did for Damadian. He became obsessed with finding a better way to diagnose and treat diseases. He saw all the flaws in existing technology and wanted to do something revolutionary, something big.
And that led him to NMR research.
It did. He started working with rat tissues, and that's where he made a huge discovery. He found that cancerous tissues, they actually give off different signals than healthy tissues when you use NMR.
Oh, wow. That's incredible.
Yeah.
How was he able to differentiate between healthy and cancerous tissue using NMR?
Well, it's pretty complicated, but essentially he was looking at what's called relaxation time. You see, when you expose atoms to a magnetic field, it takes a certain amount of time for their nuclei to go back to their normal state, and that's relaxation time.
Okay, so you're saying different tissues have different relaxation times.
Yep. And Damadian found that cancerous tissues had a longer relaxation time than healthy tissues. That was a big deal, a way to actually tell them apart.
Ah, that makes sense. So what did Damadian do with that knowledge? Did he understand the implications of that discovery?
Oh, absolutely.
Yeah.
He realized that NMR could be used to detect cancer anywhere in the body, which would change everything. He was so excited about it, you know. He even described it as doing chemistry by wireless electronics.
That's a pretty cool way to put it. So he was really envisioning a future where we could pinpoint disease without needing surgery or all those invasive procedures.
Exactly. But it wasn't just the scientific curiosity driving him either. You see, Damadian had also experienced the frustration of being sick without knowing what was wrong. He had some abdominal pain for a while that doctors just couldn't figure out.
Oh, wow, that's got to be scary, not knowing what's going on inside your own body.
Definitely. It's probably why he was so passionate about giving both patients and doctors more accurate information, taking the guesswork out of medicine and reducing all that fear that comes with the unknown.
I get that. It's so empowering to know what's going on, right? So did he try to build a machine that could actually scan a human body? I mean, it's a big leap from studying rat tissues.
Oh, he went for it. He decided he was going to build a machine big enough to scan a human, even though a lot of people thought he was crazy. He called it Indomitable, which is pretty fitting, don't you think?
Indomitable, that's a great name. Sounds like a superhero or something. So what was this indomitable machine like?
Well, picture this, a magnet so big it used 30 miles of wire. Can you imagine? This was no small feat.
Wow. 30 miles of wire. That thing must have been huge. I can only imagine the challenges he faced trying to build something like that.
Oh, there were definitely some bumps along the way. Like, there's this funny story about how Damadian's own body fat was actually messing up the early scans.
Wait, seriously?
Yeah.
His own body fat was interfering with the experiment. That's kind of hilarious.
I know, right? It just goes to show that even geniuses have their oops moments.
Totally.
Yeah.
So they ironed out the kinks, and then what?
Well, in 1977, they finally did it. They scanned a human being for the first time.
Who was the lucky volunteer?
It was one of Damadian's graduate students, Larry Minkoff. The scan itself took 5 hours to complete.
5 hours? Wow, I wouldn't be able to stay still for that long.
It must have been quite an experience, and the images, well, they were very basic compared to what we have today.
What do you mean by basic? Like, what do they look like?
Think of it like those old blocky video games. Very pixelated. But still, it was a revolutionary achievement. Nothing like it had ever been done before.
It's amazing how far we've come. So Damadian achieved his goal. He built a machine that could scan the human body. Does the story end there?
Well, not exactly. Damadian's work was groundbreaking for sure, but it was just the beginning. The next big step in the story comes with a guy named Paul Lauterbur. He brought a whole new perspective to the field, one that would really take MRI to the next level.
I've definitely heard of Lauterbur. He played a big role in this story too, right?
A huge role, and things get even more interesting when he enters the picture.
Okay, I'm all ears. Tell me about Lauterbur. What did he do?
Well, Lauterbur was a chemist who'd always been interested in NMR. He saw some of Damadian's early experiments with those rats, and just like Damadian, he was blown away by the possibilities.
So how did Lauterbur's approach differ from Damadian's? They were both working with NMR, right?
Right, but Damadian was focused on figuring out the different relaxation times between tissues, remember? Lauterbur had a different idea. He thought, what if we could use variations in the magnetic field to pinpoint exactly where those signals are coming from?
Okay, now you're losing me a bit. Can you break that down?
Sure. Think about those early scans from Damadian's Indomitable machine. They could detect abnormalities, but they couldn't really tell you exactly where they were. That's where Lauterbur's idea came in. He figured out that by using gradients in the magnetic field, you could map the precise location of each signal.
Ah, I see. Like creating a coordinate system within the magnetic field so you know exactly where each signal originates.
Exactly. And that allowed him to create two-dimensional images, which could then be stacked to build 3D models. It was a much clearer and more precise way to visualize what was going on inside the body.
So Lauterbur basically turned MRI into an imaging technology, not just a tool for collecting data. That's a huge step.
Yeah.
Did he try to patent his idea?
He did, but his first application was actually rejected.
What? Why? It seems so revolutionary.
I know, right? But the patent reviewers just didn't get it at first. They didn't see the practical implications. Lauterbur had to resubmit the application and really emphasize how his method could be used in the real world.
That's wild. It makes you wonder how many other brilliant ideas were initially dismissed because people couldn't see their potential.
It happens all the time, unfortunately. But there's another twist to Lauterbur's story. Turns out he wasn't the only one working on ways to improve MRI technology at the time.
Oh no, not another case of parallel discovery. Who else was in the game?
Well, across the pond in England, there was a physicist named Sir Peter Mansfield. He was independently developing techniques to shorten those long scan times and make the images even clearer.
So we have two scientists working in different countries, both making huge contributions to the development of MRI. It makes you wonder how you even begin to figure out who gets the credit.
That's where things get messy. All those fights over patents and recognition, and then there's the whole controversy surrounding the Nobel Prize. It's a pretty dramatic chapter in the story of MRI.
Okay, so we've got Damadian pushing the limits with Indomitable, Lauterbur revolutionizing imaging with his gradient technique, and Mansfield working on faster scan times. Sounds like things were really heating up in the 70s for MRI research.
Yeah, the 70s were definitely a pivotal time, and all this was happening while Damadian was busy building his company, Phonar. They hit a big milestone in 1980 when they released the first commercial MRI machine.
Wow, so this technology that had once been experimental was now becoming available to doctors and hospitals around the world.
Exactly. It was a turning point for MRI, but of course, with this widespread adoption came some new challenges, especially on the legal front.
Right, you mentioned earlier that Damadian was very protective of his patents. What happened when other companies started developing their own MRI machines?
Well, Damadian was not messing around. He was determined to protect his invention, and he went after anyone he thought was infringing on his patents.
So he was suing these companies.
Yep. He filed lawsuits against some of the biggest names in the medical device industry: Hitachi, Johnson & Johnson, Siemens, Philips Electronics, and most notably, General Electric.
What were the companies arguing? Did they claim they had developed their MRI technology independently?
Most of them settled out of court, and Damadian's company got a lot of money from those settlements. But the case against GE, that one went on for years. It was a real battle.
What was GE's defense?
GE claimed they had been working on their own imaging concepts from the beginning, but they were always kind of vague about the specifics.
Sounds like your typical patent dispute, right? Lots of arguing about who came up with what and when.
It was a classic patent battle, for sure. And in the end, Damadian won. In 1997, the court ruled in his favor and awarded him a whopping $128 million.
Wow, 128 million. That's huge. I bet that felt pretty good after years of fighting to protect his invention.
I'm sure it did. It was a landmark case in the world of medical patents, and it really highlighted the importance of intellectual property rights, especially for smaller companies trying to compete with these massive corporations.
You also mentioned the shift in terminology from nuclear magnetic resonance to magnetic resonance imaging.
Yeah.
What was the reason for that change?
Well, the word nuclear had, some baggage, especially during the Cold War. People associated it with nuclear weapons and radiation, and that obviously made them nervous.
That makes sense. I could see why they'd want to get rid of that association. It's a much friendlier name, right?
Yeah.
More reassuring for patients.
Exactly. Changing it to magnetic resonance imaging helped people feel more comfortable with the technology.
So that brings us to maybe the most controversial part of the MRI story, the 2003 Nobel Prize in Medicine.
Ah, yes, the Nobel Prize. It's a really interesting case study in how tricky it can be to give credit in science, especially when you've got so many brilliant minds working on the same problem.
Can you remind us who won the Nobel Prize that year and what made it so controversial?
In 2003, the Nobel Prize in Medicine was awarded to Paul Lauterbur and Peter Mansfield for their contributions to MRI.
And not Damadian.
Right. Lauterbur got it for his development of the gradient technique, the one that made it possible to create images from NMR data, and Mansfield was recognized for his work on making the scans faster and the images clearer.
And Damadian was left out. After all that work he put into building the first MRI machine, that must have been pretty tough for him to swallow.
Oh, he was not happy about it. He felt like his work had been completely overlooked, and he launched this big public campaign to try and get himself added to the Nobel Prize list.
Really? What did he do?
Well, he took out full-page ads in all the major newspapers, the New York Times, the Washington Post, the whole shebang. He was arguing that Lauterbur and Mansfield's work, while important, was only possible because of what he had done first. He really believed the Nobel Committee had made a big mistake.
I can see his point. Science is rarely a solo act. It's usually a team effort, with people building on each other's ideas. Sometimes it's hard to say where one person's contribution ends and another's begins.
That's the beauty and the complexity of science. It's all interconnected. And Damadian's strong feelings about patents really tie into this. He truly believed that protecting intellectual property was vital for promoting innovation, especially for those smaller companies that are up against these giants.
It really makes you think about the whole dynamic between collaboration and competition in the world of scientific discovery. It's a delicate balance.
Absolutely. And the MRI story, with all its twists and turns and controversies, really highlights that.
Oh, and before we wrap up, we can't forget about Vladislav Ivanov.
Oh, right. Ivanov, the plot thickens.
He kind of came out of nowhere, didn't he?
He did. Ivanov was this Russian scientist working on aircraft navigation for the Red Army back in the 60s, and he claimed that he'd actually come up with the idea for MRI back in 1960.
Hold on. Even before Damadian and Lauterbur.
That's what he said. Apparently, he was using NMR to create images of water for his navigation research, and then it just hit him. He thought, hey, if I can image water, maybe I can image the human body too, since we're mostly water anyway.
That's fascinating. It's amazing how these aha moments can come from the most unexpected places. So what happened with Ivanov's idea? Did he build a machine?
Unfortunately, no. The Soviet authorities, they weren't impressed. They thought it was a waste of time and told him to focus on his assigned work.
What a missed opportunity.
Yeah.
You really have to wonder how many groundbreaking ideas have been ignored or dismissed throughout history simply because people couldn't see their potential. But I like what Ivanov said about ideas having their own momentum. It suggests that once an idea is out there, it has a way of making itself known, no matter who gets the credit.
That's a great point. It speaks to the collaborative nature of knowledge.
Well, this has been quite the journey, from Rabi's early work to Damadian's Indomitable to Lauterbur's gradients and Mansfield's faster scans, and then we've got Ivanov over in Russia coming up with the idea independently. What a wild ride.
It's a story that reminds us that science is a human endeavor. There's passion, there's competition, there's collaboration, and sometimes there are even these incredible coincidences that shape the course of history. And the story of the MRI, with all its complexity and controversy, really embodies that spirit.
And for our listeners out there, we hope this deep dive into the world of MRI has sparked some new ideas and give you a greater appreciation for the collaborative nature of scientific progress. It really makes you wonder how many other groundbreaking discoveries are waiting to be made, just waiting for someone to connect the dots and see the potential. And who knows, maybe one of our listeners will be the next Damadian, the next Lauterbur, the next innovator who changes the world.
And maybe, just maybe, we'll be talking about your story on a future episode of The Deep Dive.
Until then, keep exploring, keep asking questions, and never stop wondering about the world around us.